All right, welcome to this explainer. Today, we're embarking on a pretty awe-inspiring journey through the 118 elements that make up our known atomic inventory. This isn't just some random assortment of materials. It's a perfectly ordered sequence that literally catalogs the building blocks of everything around us. Let's dive right in and visualize exactly how this inventory scales, breaking down the sheer volume and those fascinating patterns hiding right there in the names and numbers.
We've got to begin at the absolute foundation with number 1. In any sequence, the starting point totally sets the stage. It represents absolute simplicity, the bare minimum required to even exist on this list. From this single unit, an entire universe of complexity is going to unfold.
Okay, let's speed right through the middle of the pack and hit the midway point at 50. By the time we reach 10 here at 50, the sequence has gained incredible momentum. It really shows us just how far the progression has compounded from that initial starting block. And then we race all the way to 118. This establishes the sheer scale and the absolute edge of our source list. It's the current ceiling. Visualizing this massive jump from 1 to 50 and then all the way up to 118, it kind of gives us a map of the territory we're about to deeply explore. It's just this massive, unbroken chain.
Section 1, the starting line. Because, every massive structure needs a cornerstone.
Hydrogen is that starting line, holding the designation of a single, simple integer of 1. Just notice its stark simplicity. That's it. And from this absolute baseline, everything else in our inventory is going to sequentially escalate. It's the ultimate anchor. Moving into the familiar foundations, let's see how this builds into the framework of our daily lives. Now, what's really interesting here is the sheer visual density and weight of the list as we march from neon at 10 all the way up to zinc at 30. We seamlessly transition through familiar elements like sodium, magnesium, and aluminum in the low teens and push right into potassium, calcium, and iron in the 20s. Seeing them all populated together like this really highlights the unbroken rhythm of the inventory.
And hidden within this massive sequence are these heavy hitters, names we recognize instantly, anchored firmly to their specific integer. Oxygen sits neatly at 8. Iron is locked in at 26. Pushing much deeper into the inventory, we find silver at 47 and gold perfectly designated at 79. These aren't just abstract figures, right? They're precise addresses for materials we interact with constantly.
Next up, patterns in the elements. Let's look beyond the math at some fascinating linguistic groupings. This brilliantly illustrates how the text itself creates families. Notice the elements ending in the on suffix on the left: neon at 10, argon at 18, and xenon at 54. Now contrast that distinct group with the ine suffix family on the right: fluorine at 9, chlorine at 17, and iodine at 53. Clear linguistic categories naturally emerge, grouping these sequential items together by their very names. But actually, scratch that. There is one suffix that totally dominates the whole shebang, and that's am. Think about it. Lithium, beryllium, sodium, magnesium, the list just goes on. As the sequence expands, that am ending practically takes over the entire inventory. It becomes the standard linguistic rhythm of the elements. Pushing the limits. As we push past the familiar, the list relentlessly marches into the hundreds.
Look at this unbroken sequential sprint. We're deep into the triple digits now. Rutherfordium hits 104, dubnium at 105, seabordium at 106, right through to bordium at 107, and hassium at 108. The naming conventions become highly distinct, sure, but the inventory's steady, step-by-step cadence, it never falters.
And as we approach the absolute outer edges of our inventory, the rhythm remains incredibly dense. From meitnerium at 109, sliding through flerovium at 114, all the way down to tennessine at 117. It maintains a strict +1 increment in a relentless driving march toward the absolute end of our source document. The final number. Finally, we arrive at the culmination, the edge of the map. 118. We started with a simple 1, and we've climbed sequentially all the way up here. 118 is the current ultimate ceiling of this entire mathematical progression we're analyzing today.
Oganesson holds this final spot. Sitting precisely at 118, it acts as the ultimate bookend to hydrogen's simplicity. And hey, notice the spelling. It ends in on, decisively breaking away from those endless ium suffixes that dominated the hundreds. Oganesson is the final entry, the final string of text, and the absolute final integer in our known atomic inventory.
Which leaves us with a pretty powerful final thought for this explainer. Considering the completely infinite nature of numbers and how relentlessly this sequence marched from 1 to 118 without ever breaking its pattern, will 118 truly be the end of the list, or is it just a placeholder waiting for 119? Thanks for joining me on this deep dive. Keep questioning the sequence, and we'll catch you next time.